In this video, we're going to be looking at finding domain and range. In these situations, we are given a graph and we want to state the domain and range using interval notation. So we have two graphs here that we're going to look at. Let's look at example 1 first. Looking at example 1, we're given a graph. I want you to notice we have a closed dot and an open dot on those endpoints. Every point in this function or on this graph is defined unless it's drawn specifically with an open circle or an open dot. Open circle means not touching. So the graph is touching everywhere along these lines. We just assume these are all infinite closed dots all touching each other, all the way to this endpoint over here where we have a closed dot. All right, now let's think about domain. Domain is the set of possible x values. All right, so we need to say, where are my x's defined? So my least x value is over here at -3. And because we can touch that ordered pair at -3, I'm going to say -3 with a closed or a square bracket. And then we're going to travel along the graph, and it looks like a point is defined everywhere on the graph, and the furthest right I can go is +6. Now, because I have an open dot at +6, we can't touch that, so we would say -3 to 6. -3 included, 6 not included. That represents my domain. Considering the range, we'll go about this similarly. Now remember, range are the set of possible y values. So what is my least y value looking at this graph? The furthest down my y value goes is over here at -4. -4 is that least y value. What is my greatest y value? My greatest y value is up here at +2. So we are going from least -4 to greatest +2. My y values are always going to be somewhere in this range. Now we do need to note that there's an open circle at y equals -1. This over here on the right, this is an ordered pair, 6, -1, and we cannot touch -1 here. So the question arises is, do we need to leave that value out? And the answer is no, we don't, because we do have a closed dot. Even though we don't specifically see that as a closed dot, y is allowed to equal -1 right here. So we do not need to leave that -1 value out. And I would answer this, I would say -4 to +2. And since both of these are defined with a closed dot or something that is not specifically noted as open, we have square brackets for both of those. So there you can see we have stated the domain and the range for this graph. Let's look at the other example. For our second example, we're given a graph which looks like a parabola. We have a closed endpoint here at -5, 7. As we travel along the graph, we approach a hole at -3, +2. We continue along. Here's a low point on the graph at +1, -2. And then moving along, our endpoint, which is open over here, is at 5, 2. So I've listed those points on the graph. All right, so let's talk about writing our domain and range. Remember, domain is the horizontal span, and then range is my vertical span. And we have to look at when we draw this, if we would have to pick our pencil up, if we approach a hole anywhere along these curves. So first, let's find our domain, and domain represents the horizontal span, all of the possible x values that could fit into the solution set or that lie on this curve. So my least x values all the way over here on the left, x equals -5. And we can touch that value at x equals -5 because it's a solid dot. So I will use a square bracket, -5, and we'll continue down our curve. So we're sliding down the curve, we're drawing this. And as we are drawing, eventually we reach a hole. When you reach a hole, you'd have to pick up your pencil. So that means we only have this interval from -5 to -3. So -5 to -3. And since I can't touch -3, I'm going to draw that with a parenthesis. Now, since I have one interval and I need to connect it to the next interval, we're going to draw a union symbol. So continuing along, I'm going to start back at -3. And of course, we can't equal -3 because there's a hole. So I'm going to draw a parenthesis there. And we continue along our curve. As we continue along our curve, we do not reach any more holes until we get to our stopping point, which is at x equals +5. And of course, we can't touch at x equals +5 because there's a hole there. So we'll write this as 5, and then we will put a parenthesis on that end point. So that, what I've just written here, closed bracket, -5 to -3, open, union, open, -3 to 5, open. That represents my domain. Now let's look at my range. Range is my vertical span. It's fairly easy for us to see that we have a low y value at -2 and a high y value at +7. So we have an idea of where our range is going to start and end, -2 to +7. We have to look and see if there's a hole anywhere along this path as we travel vertically. So I'm going to go ahead and start this with a closed bracket at y equals -2. We'll look at what happens as we travel up. Is the function defined everywhere for every y value that falls between -2 and 7? And the answer is no. We have a hole here at y equals +2. What happens if we go to look at the other spot where y could potentially equal +2? We also have a hole. So that means we're going to start at -2. We're going to travel up to +2, open parenthesis, union, then we'll have 2 all the way up to +7, which would be a closed or square bracket. So closed, -2 to 2, open, union, open, 2 to 7, closed. And it is just a coincidence that both the domain and range for example 1 and example 2 looked so similar because they don't always behave that way. So just keep that in mind, always thinking about whether or not your x and y values are defined. Again, domain and range are super, super important, so you really need to practice this. You want to make sure you get this right away at the start of the semester. Please email me if you have any questions or concerns, and good luck.